So my name's Thomas Wood. I'm going to talk to you about a tool that we've developed called Harmony. So this is an open source tool that is designed for psychologists to use. And you can find the tool at this website, harmonydata.ac.uk. You can find our source code at github.com/harmonydata. So my name, Thomas Wood, and my company is Fast Data Science. So that's our URL, fastdatascience.com. So what Harmony is, so I don't know if there's any psychologists in the room, or anyone practicing. There are people in that field. Fantastic. Yeah, so Harmony is a tool that we've developed for psychologists. So the team that worked on it, it's myself and a couple of other technical people, and then mostly psychologists. It's led by UCL and Ulster University. And what it does is it uses natural language processing to help psychologists compare data from different sources, from different studies, where those studies might have been run in different locations, different countries, or different times. So our software is under MIT license. So that's great for, if anyone wants to take the tool and extend it or do something else with it, then they're not forced to make whatever they do with it public. So it's kind of quite a loose license. And the software has libraries in Python and R, and it's been funded by the Wellcome Trust. So it's not a commercial venture at all. Brief introduction to the team. So we've got these first four, Owen, Bettina, Mauricio, and George. They're academics, they're practicing psychologists, so some of them clinical psychologists. So two of them in UCL, one in Ulster University and one in the University of Santa Maria, which is in Brazil. Then there's myself and John, who are on the technical side on back-end and front-end development. And as well as the people I just mentioned, we've got, since we've managed to kind of spin this off as an open source project with people volunteering and giving up their time and working on weekends around the world, there are people, there are some usernames up there who've been contributing, from all different corners of the world. From, we've had someone from Australia that I connect with, when it's the middle of the night and things like that. So that's really, fantastic. We're really happy that we've got people who joined the project. And if anyone in the room wants to kind of get involved in an open source project, then you're absolutely welcome to join. I'm also, supposed to mention the organizations involved in this. So Ulster, UCL, Santa Maria, Fast Data Science, and of course the Wellcome Trust. So the guys who have been funding us. The project is basically attempting to follow in the steps of a lot of well-known open source projects like Ubuntu or Firefox. So, people will be familiar with those. Those are under different licenses. Or there's also kind of software packages such as Pandas, which, Hugo mentioned in the last talk. And there's a package called Psych, which psychologists are used to working with, and that's in R. And so those are under licenses like BSD, GPL3. And then Harmony, that's, again, following this tradition, that's under MIT license. So I'm going to talk a little bit about the problem set first before I show you how we work with this tool. Because people who might not have worked in this field might not be familiar with this issue. So what I'm showing here, this is a questionnaire called the GAD-7, and it's one of the most widely used questionnaires. So psychologists call it instruments. So I've had to learn on this project to refer to these as instruments, and I'll just call it questionnaire. And this questionnaire or instrument is something that allows you to measure somebody's level of anxiety and quantify it as a number. And so if the psychologist in the room, if I say anything wrong, please correct me. So typically a person, if you go to the GP, they might give you this. If you have symptoms of anxiety, they might give you this and then ask you to fill out this questionnaire, sum up the numbers, and then what's the maximum you can get? 3 times 7, you can get 21 points, and that would be the highest level of anxiety and so on. So that's all kind of straightforward if everybody in the world in that field agreed to use the same questionnaire. And now this is where we get to the problem. So Another instrument that's used for measuring anxiety is this one, the Beck's Anxiety Inventory. And so this is not 7 questions, I don't know how many this is, 20 something, I think. And if you look carefully, you can see we've got the question number 4 in the GAD-7, trouble relaxing, and then you've got unable to relax, appearing at position 4 in the Beck's Anxiety Inventory. So those are 2 kind of semantically quite similar questions. So if you imagine you're a psychologist and you are doing a study and you've got data that has been gathered across a population using the GAD-7, and they have a similar amount of data that has been gathered in a separate population in a separate study, where the 2 people, the people doing those studies didn't cooperate with each other or didn't know about each other, then how on earth can you do any kind of meta-analysis that combines them? And this is quite a common problem. So the team that I'm working with, they're specialists in longitudinal studies, which is they follow people, a cohort of people, such as young people, over many, many years. So one of the studies that they run is called the Millennial Cohort Study, and it's a group of young people who were born around the turn of the millennium, and those people have been tracked and followed until, in the following 24 years. And they were asked questions. I don't know exactly which, they might use the GAD-7, I'm not sure which one they use. And we've got a study like that, but then Mauricio and our team is also in Brazil, and they have an equivalent study in Brazil, but they wouldn't have used the same instruments. So if you then want to work out, ask questions such as, how do young people in the UK respond to changing school or bullying, and then how do Brazilian children respond, or how do Brazilian and UK teenagers react to the pandemic or were affected by the lockdowns and so on. That becomes very hard to do that kind of meta-analysis when all the data that is being gathered is in so many disparate forms. So traditionally, this is how it's been dealt with. What I'm showing here is, a screenshot of one of the Excels that's actually being used for this kind of thing. So this is a harmonization tool where the psychologists will have manually gone through and identified all the low mood related questions and found which ones match in which study. So here on the left, we've got all these, the different inventories and instruments and questionnaires that we use. And then, somebody's worked out, okay, I felt miserable or unhappy approximately matches the one about downhearted. And so we know that because we know English, because we know what synonyms are, but still, how would you quantify it? Somebody's just decided a yes or no, they should go in the same column, which is still not far from ideal. So this is a screenshot of how Harmony handles this kind of thing. So here we've got we've got a Portuguese question and an English question. And what Harmony does is it will assign a number between plus 100, being a full match identical question, and negative 100, which would be a complete antonym. And so it can actually assign that number in a very understandable way that you can work with, and then you can use that if you want to later combine data. So at this point, I'm going to actually visit the website. So you can try this tool on this URL. So I'm going to open it up. So this is what the UI looks like. So what I can do is, let me grab a file. I can upload a file. So if I upload with GAD-7 in French, for example, I can upload the GAD-7 as a PDF. And I could randomly pick a couple of the other ones, like, I don't know, that's CSD, scared. Okay, so I've just put 3 in. I should put 2 just to keep it simple. And I can click harmonize. And what I have a threshold that I can drag. I can see, okay, so it's decided I felt fearful, 66% match to this French one. So notice that Harmony is language agnostic. We're using an LLM, so as everyone knows, the LLMs now, they don't care what language you put into them, as long as it's been in their training data. So if I scroll down the results, actually, if I change the threshold a bit, we can see a few more results. I can scroll down and you see sometimes there's a negative one. I can't find a negative one now. Oh, there we are. I was happy. If anyone knows French, you can see it's like a negative match, so something that's an approximate antonym. And So you can imagine if in the case of the shoes of a psychologist trying to combine a French data set to an English data set where you don't know how, you just got a list of questions. You could use this tool. You can then work out, okay, in what way do I combine them? Or, how would I weight, if I wanted to do it as a weighted average, I could use these percentages. And then the next thing I can do, I can show display matches that are within a single instrument as well. So find similarity within. So depressed and sad, it's decided was an 85% match. I can also check the topic. So we have an integration with a tool with a website called the Mental Health Catalog. And so we've identified the topics, anxiety and depression. What I can do is click this link, I visit the Mental Health Catalog, and that's showing me the survey. So this one, longitudinal studies of parents and children, that's a similar one to the millennial cohort study that I mentioned before. So it's showing all the studies that were run in this database that match those topics I've just uploaded. And the other thing I can do, I can share it online. So there's kind of social media sharing links. So if your researcher wants to share their analysis with co-workers or just publicize it, then you can use these links, and I can export the entire thing as Excel. And if I do that, then we've got all the matches that I found, the similarity score, and then on this tab, I don't know if you can see if it's too small, there's a matrix showing the similarity. On one axis, it's the question number in one of the two questionnaires that I uploaded, and the other axis is question number in the other questionnaire. So we've got basically half of a matrix, because the other half, the numbers would be the same. It's kind of flipped around the diagonal. So how we develop the tool. So the tool was kind of developed in a very UX first kind of process, where we had workshops and we did a lot of brainstorming with, among the practicing psychologists to work out what they would expect from a tool and where the pain points are when they're kind of doing analyses of longitudinal studies. And, we started off with kind of printouts of what it was going to look like on paper, and then we got them to annotate what wasn't clear, what wasn't understandable, what was understandable, and then that gradually took shape as the tool. How it actually works is we've got really 3 steps. So first, a PDF is uploaded, and then we have a non-trivial step, which is loads of kind of NLP logic, loads of complicated logic to get the questions out of the questionnaire, because there's things like there's copyright statements at the bottom and all kinds of things that you don't want, that is not relevant. So that in itself is a major headache. Secondly, the questions themselves are passed through an LLM to convert them to this numeric representation, the embeddings, sentence embeddings, and then thirdly, we calculate the similarity between them. So what I can do here is let me see if I can just explain a bit about the embeddings. So, the sentence embeddings, you may or may not have worked with these before, but basically what we're using is a library called Hugging Face under the hood, and it's a library which would allow you to take a single word and convert it to this vector representation, or take an entire sentence and convert it to vector representation. So what I can do is I could actually show you how individual sentences are converted. So let's say if I've got this sentence, I feel sad, that is converted to a vector of, I think it's length 712 or something. So I can put that in a variable and then try, I don't know, depressed, yeah. Maybe this is not the best example. Depressed. So if I take those 2 variables, I can then just call the cosine similarity function. And then, I'm getting 82% similarity between sad and depressed. And then if we try something that's a complete antonym of that, like, or something that's quite far away from that, let's say happy, then you would expect a much lower degree of similarity. So we get just 55%. So that's kind of the basic behavior with the LLMs, how, LLMs will, such as GPT or whichever one you want to use, they generally tend to convert sentences to a single vector. And then we use a cosine similarity, which is also, the dot product, you may have learned dot product in school, and then things that are very similar in meaning end up being very close together in these vectors, and their cosine similarity ends up being close to 1. And harmony has a little bit of extra magic that lets us work out if things are opposites, like antonyms, and that's where the negative numbers come from. What we've also got on our website is, loads of examples in Google Colab. So examples in R, examples in Python of how you can actually use Harmony, as well as using it in the web UI. So here's a kind of visualization of how Harmony internally represents values as vectors. So really all the vectors that Harmony generates are of length 1. So they're in a sphere of really, really high dimensions. And concepts like sad and depressed, if we imagine this as being a sphere, they would end up being quite close together. And then one of these examples, for example, child is bullied, which is, one of the ones that quite often comes up in the questionnaire, that would end up being further away. And so the cosine similarity between these two is quite high, and between that and that is quite low. Or the other way you can view it is a dot product. So what we've also been doing is validating this tool against against real harmonization tools that existed that have been created manually. So and we were able to change the inside of Harmony. So the one that's on the website doesn't use OpenAI, it doesn't use any paid LLM, it just uses the basic one that we can host on our server, but we can also switch it around and use Google. And if you download it and run it locally, you can use your OpenAI API key or a Google API key. So we found that things like Google and OpenAI, the paid LLMs tend to perform better. So if you want to do, really care about your analysis, this was a matching of the GAD7 in English versus Portuguese, Spanish, French, lots of different languages, just working out how well did it match it up. So there are LLMs which were only trained on English. Those ones don't manage to do anything. They don't match any English questions to any French questions at all. They're just no better than rolling a dice. And they're multilingual ones. So we've made sure that Harmony is generally using multilingual ones. And so on the right, I've also got the analysis that we did of against the data set of the questionnaires that the psychologists have manually harmonized, just to work out how well it agrees with that. So in general, it agrees pretty well with what humans have manually produced. The other thing that we've checked is how well do the correlations of what this tool does, how well do they correlate with real life questionnaires? So what you can actually do is run these surveys in the wild. So psychologists will have things like a factor model. So when they take what they call a factor model, so if they had one about 40 questions about anxiety, they might work out, okay, if we look at correlations and group together everything that's strongly correlated, we find these 5 questions grouped together, these 5 grouped together, these 5 grouped together. So what I'm showing here is one of the sets of questionnaires where they actually gathered real data from real people responding to them. And we found that, how well, we basically plotted a graph of how well Harmony's prediction correlates with the real world prediction. So in reality, Harmony is giving us numbers between like 0 and 1. And in real world, things tended to have correlations between 0.5, 0.7. So they're a lot flatter, but overall it predicted it quite well. And we found that there were cases where Harmony didn't pick things up. So an example was anything about high blood pressure and anything about increased heart rate. Those things, because they are things that co-occur in the real life, because they're both caused by somebody being anxious or being stressed. So high blood pressure and high heart rate, they would correlate, but Harmony would not pick them up because semantically they're different concepts. They're not, an LLM is not trained to know that those are the same thing. And in fact, they're not. So we're kind of trying to work out how to use this and what to expect from it as well, because it's quite an interesting area. Like, where does an LLM like OpenAI is, or the Hugging Face one that we're using off the shelf here, it's been trained on news text and internet text. It's not been trained on text in the psychology domain, and also nobody has told it that blood pressure and heart rate should correlate, which is what we would see in the data when we run it against real world data. And so this is just another of those graphs where I took I worked out the correlation coefficient between the Harmony that's running on the internet, and then how well does it work if we use Google Vertex AI, or if we use OpenAI and ChatGPT and so on. And so in general, with the same thing happened, that OpenAI and Google and Microsoft and all of those paid ones tended to outperform the free models, even when predicting the correlations, like the real world correlations in when they ask real people questions about anxiety and look at the data set across the population. So the next part is really how we want people to get involved. So if you're interested in getting involved in this project, you can go to our GitHub, clone it, fork it. We have a Discord server. We have a link that you can join Discord on our website. You can run our API locally. You can run our, you can try, if you like programming in R, you can use Harmony in R, and you can make pull requests. And also, if anyone is in research, we're interested in hearing about you using this tool in research. If you do use it, please share, cite us, promote it, and so on. Another thing is we're planning to run a hackathon in June. So that hackathon, we're kind of putting together ideas of what we're going to do in the hackathon at the moment. But yeah, the main thing is the difficulty of processing PDFs and reading questions out of a long questionnaire, or, and we're also interested in improving the matching algorithm, how it identifies matches, trying experimenting more with different LLMs, adding on the website, adding the option to, maybe you could cut and paste your OpenAI key, or, we've got a list of ideas that we've been putting together. So if anyone's interested in that, we're glad to have you come along. The next step's really like, where are we taking the project now? So we're waiting for another funding application, but we're exploring, we're already integrating with the mental health catalog, so with one database, but we'd like to integrate with a few others. So there's one called the UK LLC, which is a repository of longitudinal data sets. And then we've encountered a lot of cases outside psychology. So we spoke to people at the Australian Data Archives, which is the national data archive in Australia that stores kind of questionnaires around really anything. Like, they would have, one of the ones I looked at was like rat population in Tasmania, and it was like a list of a questionnaire that they sent to people who had rat infestations, and they were using, we were talking to somebody who was doing that and taking those questionnaires and putting them into this tool. So that was quite interesting. We found we think that maybe people in market research will be interested, because I found a few companies that do, when Nescafe or Pepsi or whoever is putting out a product, they will take 1,000 survey respondents and ask them a question. Do you like this packaging? Do you think it matches our brand? Do you like the taste? Do you think this tastes better or worse than Coke or whatever? And they ask those questions, and they do it again and again, year after year, in different countries and different languages. And so I think that's also a use case that we might, I'm interested in exploring. Pharmaceuticals. So in the pharma industry, when they start running a clinical trial, they ask an informed consent form they send an informed consent form to all their participants. And I spoke to people at one pharma company where they had acquired a different company, and they had all the consent forms that from all the trials they had run. And the consent forms are things like, we can keep your tissue sample or your blood sample for 2 years or 3 years, or whatever. And if they get those from different trials that they've run and they suddenly have that all under their responsibility, then how do they manage it? So I think that's another use case. Similarly, like really any other area like finance, I'm sure there's applications in finance. So we're really interested in hearing about any ideas of where we can take this, what else we can use it for, both within and outside psychology. I'm not trained as a psychologist. I've only my only experience of psychology is this project. So I'm really interested to see where else we can take this. And we're interested in more collaborations with more organizations as well. So that's really the end of the talk, but I'm putting the contact details up here. So these are our Twitter handles, website, and this is the link to our Discord. So it's Discord/HarmonyData. That is also on our website. So all of these things are linked from harmonydata.ac.uk, and you're welcome to go clone our repo and just let me know, make your changes, submit them. That's it. So any questions really? Okay, do you want to go first?
The cosine of any value goes from 0 to 1. How do you assign negative scores for Antonians?
That's a good question. That's kind of an add-on to the cosine. Yeah, so the cosine isn't necessarily between 0, it would be between 0 and 1 in 3 dimensions, but I think in multiple dimensions it can be negative. But the negative values that you're seeing, they come from, what we do is we take the original sentence, like sentence A, we take sentence B, we make the embedding of both of them, and then we get the cosine. And then we do a little hack. We put a not in the middle of the sentence, or if there's no not, there's already a not, we remove it. So like I wrote a little bit of code that would turn a negative sentence into positive and positive into negative. And then if it's closer, if I've negated it, then we say, okay, this was a negative match. So it's like a extra add-on to the cosine. Yeah, it's not really scientifically valid, I think, but it seemed to work. Oh yeah, you go ahead.
Yeah, what sort of words would result in a 0? Like basically some orthogonal.
I don't know. I've never seen a 0, to be honest. I've seen like low numbers, but I've never seen a 0. Okay. Yeah, I think because we're in really, really high dimensions, the probability of having a 0 is like almost 0, isn't it? Because if you're in 2 dimensions and you randomly put stuff on a circle, the chance of 2 things being orthogonal is quite high. Like some of the time you'll get a 1, some of the time you'll get a 0. When you're in that many dimensions, I think things just start to behave really weirdly, and it's like the curse of dimensionality. Yeah. Wait, who's the next one? Sorry, you're the one.
Actually related to that point, have you considered the impact of taking a different measure for the distance?
Euclidean distance. Yeah, I thought about it. I think it wouldn't really make a difference, because it's like when the cosine distance increases, Euclidean distance increases. So they're what's it called, like monotonic, I think. So it will just like have a bit of a scaling factor, a bit of a distorting factor, but I don't think that it makes a massive difference. I think when you're on unit spheres, the cosine is generally the best measure. Like if you weren't in a unit sphere, then Euclidean might be worth trying, but I'm not too sure. Maybe there's like research into it. I don't know. You wanted to say something? Yeah.
Yeah, I'm just curious. Like, is there room in your conditions to have like a set of text that has nothing to do with emotions? So like, these mashed potato, this mash is made of potatoes or something. So you have like a comparison of like what the emotion cosine similarity values look like versus things that have no emotions. So it's not really, I mean, nothing about it is really married to the idea of emotions or like even psychology. So you could like,
the only part of it that is really domain specific is the fact that it looks for the closest match to the mental health catalog and then links people there. Every other part of it is completely like domain agnostic. So that's why I think like we could
It's
take
kind
it.
of like it's the problem with the instruments themselves as well, where they all talk about something that is relevant to the instrument.
Oh yeah. I think yeah. If you were to take a psychology survey and then take like a
We
market,
we need people talking about mundane stuff for rating.
Yeah.
stuff in the middle of the actual.
Oh, I see what you mean. Like to see a zero correlation in the real world. Yeah.
Yeah, like to compare it to things that don't evoke that particular thing that's being
Yeah.
talked for. So
That would be interesting to. Yeah. I don't know.
that's a
Like
general-
that's yeah.
that's a
We're kind of.
field thing as well.
Yeah. Exactly. Yeah. It would be interesting to try that. Yeah. Go back. Hi.
I'm curious about PDF parsing, but like they deal with like unstructured PDFs or
No, they're completely, they can be any structure. Some of them are even scanned documents, which is like the worst, like the pathological case is, like a grainy scan. But if there's a table in it, then it's helpful. If there's numbers in it, it's helpful. But like, they really they don't follow any rules. So that's why it's the PDF parsing is particularly like problematic. Like every time we think we've fixed it, then we see something new that we didn't think of.
so you do some sort of like sentence segmentation or chunking after
Yeah,
tracking the text.
we're kind of redesigning that because it's kind of grown organically over time. Like we just hack something together. Each time something breaks, I was just adding another hack to fix it. So yeah, but it's overall, it's split into words and we kind of classify. We have a bit of machine learning and a bit of kind of rules on top of that for when the machine learning doesn't work. So that's kind of something that we want. If anyone has ideas, we're kind of keen to kind of get contributions about that.
Since you're using LLM, so how do you deal with the issue of hallucinations, or how do you track that there is no
Well, it's not because it's not really generating. We're just using it to kind of convert the text to a vector. So I don't think there's really an equivalent of hallucinations in this use case. Like Harmony never generates text. If it did, yeah, then that would be an issue. But like, I guess the worst thing is like it misunderstands something and thinks something is similar when it's not.
So you're not using a RAG,
No.
but you're using a vector database, and which one?
We're not. Well, oh yeah, the lookup to the mental health catalog is like I just turned it all into a vector, but it's not even a database. It's just like it's only about I don't know, like 4,000 or 5,000 questions, so they can just be stored in memory. So
you're not inserting any documents or data. There's nothing.
no, apart from like this thing where we negate the sentence, that's the only modification we do to the text that you upload. So it's like quite simple. It's not like
It's not like a fully RAG.
no.
And what LLMs?
It's using a Hugging Face sentence transformer. Can't remember the exact name of it, but it's like the basic one. I think I've got it there. Let's see. Yeah, that's the name. This is the LLM that's using sentence paraphrase multilingual. Yeah. So if you want to try using that one, that's basically what it's using. Yeah.
I'm wondering about academic sort of literature and reproducibility. So are you doing any fine tuning from it? Or are you just using the model, the embedding model?
We're just using the embedding model out of the box. Yeah, we didn't fine tune it.
And have you found is there sort of a hesitance from sort of the academic community to say, for example, if they wanted to use the similarity? Obviously, it depends on the model. Or fine tune the model, those scores will change a little bit. And so if you think about combining, using them as weights to combine sort of scores and do like meta-analysis. Is there any sort of concern about that? I mean, I think using neural networks in general for sort of, social sciences and things like that.
I think one question we had was like, how could the academics use it and report it? Because they're used to like psychologists' way of working is often that they would like, let's say, have a hypothesis that, I don't know, teenagers in the UK respond differently to teenagers in Brazil to bullying or something like that. Okay, and then they would like collect some data and then do some p-values, do some statistical tests. Like, so like, how does this, Harmony is producing cosine similarity score. So how does that fit in a framework of p-values? And I think all they could do is just report the value and say how it was calculated. And I think one consideration would also be like the psychologists have to, when they run their experiment, they have to define the experiment, run it, and then report the results. If they were to like try Harmony, try all these different LLMs, and then pick the one that like cherry pick one that gave the best results, that would be like violating the scientific method. So you want to avoid doing that. So I think that's something they'd have to pay attention to as well. Like decide at the outset how they're going to use Harmony, and then stick with it, and it will just be a tool in their research.
As anybody that you know used it and sort of used the similarity scores and like computed metrics or statistics and published them?
Outside the research group that's working on this, I'm not aware of anyone actually publishing anything yet, but it's quite new as well. So yeah, I'm hoping that will happen. Yeah.
A quick question. I know this cosine similarity that you said versus 0.82.
Yeah.
Cosine similarity sad and happy. Shouldn't that be like opposite? Like
it would be, but this is I'm not using that like negation thing. So this is just like how the LLM out of the box does it. Yeah. But like if I was.
But you don't use the negation.
Yeah, not in this case, but I just wanted to like keep it simple for this example. But yeah, like it would give you negative. Yeah, you're right. Yeah.
I think one reason that the cosine similarity is not completely zero is because there are other words in the sentence.
Yeah. I think there are other words in the sentence. I think let's try. So what happens if I just do a single word? I think it would still not be zero. I think it never gets to absolute zero. But yeah, you're right. It's closer to zero, isn't it? It's 42. And like what's really cool is like, you could try, I don't know. So let's try Spanish word for happy or something, and you get it works. You can put any language in there. It's just working out of the box. Yeah. So like before the sentence transformers came out, the most you could do with the word vectors was a vector like for each word in the sentence individually. But now this is basically the innovation of the last 2 years that the entire sentence can be converted to a vector that way.
Maybe in interest of time, one or two more questions.
Okay.
Yeah. Sorry, there was a slide on validation. I just wanted to ask what sort of validation process what metrics did you apply, and how did you decide that something is false positive, true positive, false negative?
So it comes from the manual data set. Let me find it. Yeah, I got it here. So, yeah, so this is basically the Excel that before I started on the project, the psychologists working on this project built this, and they did it manually. So they've gone. It's hard to see here at this scale, but basically they made a set of adulthood measures and a set of childhood measures, and decided. So this is a children's one. So there was, so all of these are like different instruments that were used, over the, since the 1950s. Because when they want to do really, really long range studies, then they have to look back in time, and concepts like the pandemic wouldn't have been in an instrument that was made 10 years ago, and and then the social changes that happened in the 30 years or something mean that instruments are very old-fashioned in the past, but you still want to match them up. So this is all of this Excel has loads and loads of columns. So this is basically my ground truth for validating it. So if Harmony puts worries about many things and has many worries, often seen worries, in the same column, if it can reconstruct this Excel, then like that's a high score. If it puts everything in a different place from where humans put it, then it's a low score. That's basically the evaluation metric. I mean, that's one, and the other one is the real world surveys and the data gathered kind of by running the surveys.
I ask because this is a medical context, right?
Yeah.
You're talking about psychology, matching some words and not matching others could have a lot of impact on patients in the
Yeah, I mean, it's used for studies, like retrospective studies, so it's not necessarily,
So
yeah.
The use case for harmony is really research. Right?
It's research, yeah, it's not clinical practice. Like maybe somebody could find a way to do that, but yeah, I think at least that's not what it's been envisaged for. Yeah. Okay. Thank you very much.